So, welcome to our math presentation, and today we're going to be learning about the word diameter. See, now a diameter is of a circle is a segment that contains the center of the circle and whose endpoints are in the circle. The team diameter can also mean the length of the segment. Alright, now it's time for minor arc. See, a minor arc of a circle is any segment shorter than a semicircle. And now for radius. Now, a radius of a circle is a segment with one endpoint on the circle and the other endpoint at the center of the circle. And now a semicircle is half of a circle. Here's an example.
Alright class, my name is Brock Ferrada, and we're going to start off from where we left off at the circumference. To find the circumference, you will need the formula C equals 2 pi r, which is, in this case, it's 9, and you plug in to solve for the circumference, and there you go. Next up, we're going to move to intersecting tangents, which is basically you just subtract the 360 circle minus the degrees, and that will equal x, which is this angle. Alright? To find the equations of circles, you use the formula parentheses x plus 3 squared plus parentheses y minus 1 squared equals 16, which is, in our case, that's how you can graph it. To solve for our described angle, we have to use the arc provided, which is 124, to find the described angle x. And to find that, you divide 124 by 2, and that will equal your described angle, which will be x equals 62. To find the arc length, you will need to use the formula AL equals n over 36 multiplied by circumference. And in our case, that's 60 over 360, which will equal 8 pi. And you multiply 6 to 8 pi, and that will equal the arc length, 48 pi.
Hello class, my name is Alfred Burgess, and we're going to start off where we left off with example problems. We're going to start off with area of a circle, which to solve would be A equals pi r squared. Now we're going to move on to central angles, and since there are 360 degrees in a circle, multiply each percent by 360 to find the measure of each central angle in the circle graph. Now we're going to go to intersecting chords, which are these, not diameter, because they don't go across stuff. So it would be this, and then chords AC and BD intercept two pairs of opposite arcs, arcs AB and DC and AD and BC. So now we're going to move on to intersecting seconds. A second is a line that intersects a circle at 2 points. Line AB is a second ray, and AB is a second segment. The word second may refer to a second line, second ray, or second segment. Damn, that's a lot of seconds. Now we're going to move on to our final one, which is sector area. So the area of a sector of a circle is a product of the ratio, and the area of a circle, area of sector ADB equals measurement arc AB times pi r squared over 360.